Today's lesson will focus on neutralization reactions for acids and bases, and then a technique called titration, which is one of the most precise and accurate ways to carry out a neutralization reaction. We've seen neutralization reactions a few times in our science courses, so you should have been introduced to them in grade 10 science. And when we did chemical reactions back in Unit 2, we commented on the fact that a neutralization reaction is a type of double displacement reaction, so down here, made up of an acid reacting with a base, and usually will form salts and a water molecule. And remember that a salt is just a fancy term in chemistry for any ionic compound that is made up from a base and an acid. So the cation, the positive ion, comes from the base, and the anion, the negative ion, will come from the acid. Salt could actually be table salt, so it's possible that it could be sodium chloride. But in chemistry, a salt just refers to any ionic compound derived from a neutralization reaction. When you are carrying out a neutralization reaction, a titration is one of the most precise ways to get the exact point when your acid and your base has been neutralized. So it is a method for determining usually the concentration of one of your acids or bases. So typically you'll know the molar concentration of the acid or a base, and then you're trying to pinpoint the exact concentration of, the other reactant, so the other acid or base. And we basically do some stoichiometry to figure out the exact molar concentration of one of these unknowns. And it is a method that works really well due to the precision. When we carry out a neutralization reaction, we use something called a burette. Okay, so a burette is this glass tube that is graduated. They're usually 50 ml burettes, so they'll hold 50 milliliters of solution, and they're very narrow and they're very precise. So you can accurately get a volume of an acid or a base that would go in there. So we say that the standard solution is filled in a burette. The standard solution is typically the solution that we know the concentration of, the molar concentration. And we typically put the unknown concentration solution in the Erlenmeyer flask down there. Now, acids and bases are typically colorless, transparent liquids that look like water. So how can you tell the difference between an acid and a base, or how can you even tell the difference when your acid or base is neutralized? We always add an indicator to our flasks. So the indicator is something that will change color once our solution becomes neutralized, and then we know that's our indication that the solution has been neutralized, and we can stop the titration process. So the standard solution is slowly added, like very slowly, drop by drop, when you're getting close to the neutral point, to the unknown solution in our flask, in our Erlenmeyer flask. And as you mix these two solutions, you're going to slowly neutralize your acid or your base until both of them are completely neutral and you only have that salt and water left over in the flask. So with this type of technique, there are some terms that you have to know. So standard solution, we mentioned that in the previous slide, is the acid or base solution whose concentration is known. Okay, so we know its molar concentration, and that is typically what goes in the burette. Very rarely would it not, it would be the opposite. Typically, this is how we set up these titrations. The term analyte. Analyte is the solution whose concentration is unknown, and this goes in your Erlenmeyer flask. So when I worked in the food industry before I went into teaching, I typically had to do titrations for a variety of things. I worked in a food lab, and oftentimes they would bring in samples of vinegar for us to test the molar concentration of before they would put it out in the, the cooking area where they would make sauces with it and ketchups and different things. So when I would carry out a titration, my analyte would be that vinegar that I would put in an Erlenmeyer flask, and my standard solution would be some sort of base, usually sodium hydroxide, and I would carry out my titration and then, figure out the molar concentration of the vinegar. And if it was in the range that we needed at the factory, we would proceed. If it wasn't, we would send it back. So how do we know, again, that the neutralization has taken place? We need an indicator. And when that indicator changes color, we call that term endpoint. And then there's also another term called equivalence point. And this is the point, this is important here, at which the moles of hydronium from the acid will equal the moles of hydroxide from the base based on the mole ratio of the reaction. Okay, so if it's a 1-to-1 mole ratio of acid and base needed, then your moles would be the same. It could be a 1-to-2 ratio, depending on the formulas of your acids and bases. So the equivalence point, when it's neutralized, it might be a 1-to-2 ratio that you need. As you go through a titration, this is just a couple of visuals to show you. So there's all kinds of different indicators that you can use, but typically, if you're going for a neutral, like a neutralization, a true neutralization, we love this indicator here that is called phenolphthalein. Okay, and it's got a crazy, so it's phenolphthalein. Okay, and it's got a big long name, and it is an indicator that is colorless in acid solution. So I just know, based on looking at these pictures here it's colorless, and when it's colorless, that means that it is in an acid solution. And so what that's telling me is that I got base in here, and I'm going to add this base drip by drip by drip into my Erlenmeyer flask. We're going to swirl the flask around, okay? So you're going to constantly be moving it around and mixing the two solutions. And then eventually, I don't know if you guys can see this, but down here, you're going to start to see a little bit of pink color show. And as you swirl the flask, it'll go away. And then you slow down, the valve right here. So you truly just have like a drop of base coming out, one at a time. And one drop should turn the whole solution a pale pink color. This is actually a little bit too dark pink for my liking. But when that happens, then we know we have truly just hit the neutralization point or equivalence point of that acid in our base, and our reaction is complete. Now we will practice the titration technique in our class, but we also have to do calculations associated with it. So here's an example. It says, suppose 75 mils of hydrochloric acid was required to neutralize 22.5 mils of 0.52 molar sodium hydroxide. What is the molarity of the acid? So here is our three-step stoichiometry. This is not a limiting reactant question because HCl is a reactant and we're asking something about it. So first thing that you would have to do is write out your balanced equation, come up with your products. So again, this is a double displacement reaction. So outside ions go together, inside ions go together. And then we follow our 3 steps, right? So we're going to find the moles of the given right here. This is step 1. Then we're going to mole ratio. This is step 2 over to hydrochloric acid. And then we're going to find either the volume or the concentration, right? It just depends what they ask. In this case, it is concentration of our unknown, which is hydrochloric acid. And when you do this calculation, there's your answer right there that you should be getting. So we want you to try this. You've seen stoichiometry already. You can do it. And then once you finish that, you'll be able to keep on practicing with these 3 questions as well. And again, make sure that you write out the balanced equation first. Sometimes these are 1-to-1 ratios and sometimes they are not, which will change that second step when we do the mole ratio, set that up. Good luck.